Welcome to MRU E-Learning, powered by Malla Reddy University. I am M. Srikanth, Assistant Professor, Information and Technology Department. So today's topic is about artificial neural networks. So in today's topic, we are going to learn about definition of the neural network, basic structure and design of a neural network, types of neural networks, real-world application of those neural networks, and challenges and limitations, and what are the future about these neural networks. Okay. So, in order to understand a neural network, we need to know what a neural network is built of. So, what are neural networks? Artificial neural networks. Artificial neural networks are nothing but these things mimics the brain anatomy by using a particular mathematical function simply called as a neuron. So, why we need these artificial neural networks? We need these artificial neural networks in order to maintain a high efficiency while computing and while performing tasks which may or may not take highest amounts of time. So these neural networks are formed by using basic mathematical functions called as neurons. These neurons are inspired by our human anatomy, human brain, which have a similar structure. So what happens over here is these neurons will have made up of dendrites, axons and synapses. These neurons, which are biological neurons, contains dendrites which receives our input signals and transforms them inside this nucleus, which in turn gives information for other neurons through axons which have synapses as their main part. Okay. Next, coming to the neural network, we have artificial neural networks. Neurons are made up of these 5 things. First one is an input layer which receives the information which is required to be for the producing of output. So these input layers will have the information which required for producing a certain output. These inputs are given to the hidden layers which have the neurons. These neurons are mathematical functions which will perform some operations upon activation. Each neuron will activate through an activation function, and this mathematical things which happen over here, functions, will be provided to the output. So we have certain number of input layer will have a certain number of parameters which will be passed to the hidden layer neurons, which will be again passed to output layer after performing the mathematical operations. The connections are nothing but the weights that we produce in this particular scenario, and activation functions will tell which neurons to fire and which neurons shouldn't. Okay. So while training, how we produce this output is through training. So how we train is we will have a forward propagation which will take the inputs from traditional mathematical functions and give them to the neurons, and each neuron will produce an output upon activation function being enabled, and this will give us to next layer of the hidden layer. Upon this, we will have an output produced from all the hidden layers, and this output will give a prediction. So this prediction is compared with a true value that is already been there, and a loss function is contributed. This loss function will give us a loss score which has to be low in order to give an accurate result. So if this is not low, then this loss score will give us to our optimizer, which will adjust the weights of these neurons, produces a backward propagation format. This is a backward propagation from loss score to optimizer, optimizer to weights. These weights are then updated, and again it is given to hidden layers. So this is how a particular training of a neural network will happen. It is an iterative process until this particular loss score given by the loss function is minimized. So there are different types of neural networks for different usages. There are feed forward neural networks which are for basic understanding of every hidden state. So this is like a simple one-way flow where input layer gives information to hidden layers and hidden layer gives us to output layer. So next we have convolutional neural networks. These convolutional neural networks will perform operations over images. These are for every mathematical operation like classification or regression, these kind of things, whereas these CNNs will perform operations for images, over images and videos. So this convolutional neural networks will perform for images, and these recurrent neural networks will be helpful for time series or predictive analysis over words or sentences like textual data. This recurrent neural networks will do. And generative adversarial neural networks, GANs, which we call commonly, will be used for producing new data like augmented data. So this is of different types of neural networks work. So feed-forward neural networks are for simple calculations like regression and classification, whereas convolutional neural networks will be used for images, and this recurrent neural networks, which RNNs we call, are used for textual data and time series data, whereas this generative adversarial neural networks for augmented data. So coming in depth of CNN will have different types of layers consisting of different type of functions. First, we'll have a convolution layer which will perform operations by forming a filter kind of thing, where these filters will perform convolution things and convolution process in order to determine whether there is an edge, corner or anything in this image in order to give them to the next layers. Next, we'll have a pooling layers. Generally, max pooling will happen. So where this dimensionality will be reduced, spatial dimensionality of this input will be reduced after convolution. So this max pooling layers will again give to a fully connected layer, which will flatten the entire structure of the convolution layer and max pooling layers, and will give us an output like whether it is a bird, it is a sunset, it is a dog, it is a cat. The probability of being a bird, the probability of being a sunset, probability of being a dog, and probability of being a cat will be given. So depending on the highest probability, it will determine whether it is a bird or a sunset or a dog or a cat. So this is how a convolutional neural networks will work. Next, we have RNNs. In RNNs, we'll have recurrent neurons which will have an hidden state which remembers the previous data. Okay. Next, we will have an RNN unfolding, which is like we'll have a series of things like this, hidden states, which will have mathematical functions which remembers the hidden state and also gives data to the previous thing, gets data from the previous timestamp. So how this works is, when we give an input to an RNN network, this RNN neuron will produce some output and remembers that as an hidden state. So this hidden state, again, what this hidden state will do is, this hidden state acts as input for the next time series. So applications where we apply these RNNs is, we'll apply them as NLP things, which is like sentiment analysis over text or like that. Also we'll have it on time series analysis. Next, in this particular structure of a neural network, what will happen is, in this optimization algorithms, as we have seen this, in the structure, we have backward propagation and optimization. Optimization will have an optimizer which reduces or which gives us, so this optimizer, what it will do is, it will create a particular mathematical function which will update the weights so that the loss score, whichever is produced by the next output, will be lesser than the particular loss score that we have. So we have different types of optimization functions. One is gradient descent. This works in the place such that it will be like a hill. So it will try to minimize the loss function so that we will have the best loss score in the entire network. Next, we'll have ADAM and RMS prop, which gives each individual parameter will be taken rather than the entire structure, and it will update the weights for each individual parameter. Next, we have SGD. This, instead of taking the full training set, what it will do is, it will take the batches. So it will take each batch and then reduce the input, reduce the weight in such a way that it will cover the loss function. Okay. Next, where these ANNs are used is, first we'll have healthcare in order to determine whether a patient have a cancer or not, like that. And we'll have finances, where it will predict the next stock that is going to get, or what is the spend of this particular years worth and what will be the next year's thing. And autonomous vehicles, like we have seen Tesla and all, these things use CNNs in order to determine whether we have an object on the road or not, and then we'll have autonomous driving capabilities and social media in order to know which topics are trending, which are being seen in what particular regions and all. And we'll have customer support in order to reduce number of human intervention. We can have AI calling as a personal assistant and as a customer support assistant in order to have a conversation to solve a daily occurring problem. Next, we have challenges and limitations in this, because not everything that we have will perform 100%. We'll obviously have more challenges. One is data dependency. That means in order to train a network, we need at most amount of data, where acquiring of these data is a bit problem. Next, computational power. The computational power required for training a neural network is high when compared to a traditional program, because it will have a number of decisions to make. So that is one more problem. Next challenge is overfitting. If at all we have n samples of training data, this particular neural network, if it is not properly trained, that means not properly built, it will train over the training data over and over again, making it an overfitting. And what this will do is, this will perform well over the training data. When coming to this particular testing data, it will fail. There is one more problem called underfitting. This is quite opposite of overfitting, such that the training data will be less, so it will not perform well over the new samples that we are going to have. Next, interoperability. So it cannot be like we have this interoperability and training time are limitations for this particular ANN, where training time, depending on the number of parameters and training data, it will differ. Next, so what is the future of this particular neural network? So where it is going towards? So we have attention mechanisms. Emerging trends of neural networks will have attention mechanisms. These attention mechanisms will focus on important things rather than the entire context. So what is the important context of a particular conversation or particular training will be taken into consideration, and focus will be over that rather than on the entire training. So next we have transformers, which are like a huge mathematical functions which helps us to generate output much faster compared to the normal neurons. Next we have GANs. As we seen, GANs works as augmented data producers. So what are the impacts of this is automation of tasks, which we call as some tasks which we need to perform daily or repeatedly can be automated over this. And next we have personalized medicine. That means it will personalize your particular daily routine or daycare or what medicines you have to take in order to maintain a good health. Next we have an enhanced decision making, which means this will produce decisions quickly and it will produce accurate decisions. So it will help us decide on whatever we need. This is it. Thank you.